We need sustainable growth.
We attribute
Innovation is the key.
mankind.
There is alarming evidence. Don't have time to lose.
The time is now.
You got all of it.
We don't make we have lost future.
Good morning to Europe and good afternoon to those of you watching from COP28 in the United Arab Emirates. Thank you for joining us today and welcome to this discussion on how Copernicus data can help us with our shared future. I'm Ruth McAvinia from ECMWF and you join us here in the studio in Brussels. If we can have some help from the gallery first, we have a Slido question for you all. We want to know which of you before this particular COP28 side event had heard of the Copernicus services in the last 12 months. It's straightforward, just answer yes or no, please. We'll also be using Slido throughout today's presentation to give you an opportunity to ask questions of our audience, from the audience of our panel here. Today, we're being joined by Dr. Samantha Burgess from ECMWF, Dr. Andrea Kaiser-Weiss from the Deutsche Wetterdienst, Dr. Bart van den Hoek from Deltares and the IPCC Working Group 2, and Dr. Sten Janssen from VITO, the Flemish Research Institute. All of them will be looking at ways in which Copernicus services can help with the green transition and Green Deal in Europe and around the world. So looking at our poll so far, it's good news. At least many of our audience have heard the Copernicus services recently. But for those of you who've been voting no, let's take a quick revision course of Copernicus program and the services it provides. So we start with a slide of our host country of the United Arab Emirates for this year's COP28. This is the very recognizable image of Dubai, of course. And this was taken by Sentinel-2 satellite, just one of the satellites that are part of the European Union's Earth observation program. I'm just trying to invite the slide along there. Yes, now we have the Sentinel satellites. They're part of the data collection service, but we also have other contributing missions and in situ observations back on Earth that put all the data together to help us to get a picture of our planet. Of course, the Copernicus program is managed by the European Commission and it's implemented in partnership with EU member states, as well as the European Space Agency, the European Organisation for the Exploitation of Meteorological Satellites, also known as EUMETSAT, the European Centre for Medium Range Weather Forecasts, ECMWF, along with EU agencies and Mercator Ocean. Why is it called Copernicus? Of course, it's named after Nicolaus Copernicus, born 550 years ago. It was his astronomical model that put the sun at the heart and the centre of our solar system. The services bring together vast quantities of global data and, along with interpretation and scientific expertise, helps to make information available that will help European citizens' daily lives and help solve global problems. The information services from atmosphere, marine, land, climate change, security and emergencies are all available free and easily open to users to take up. So we start with the land monitoring service. It was one of the first to become operational back in 2012. It's implemented by the European Environment Agency and the Joint Research Centre of the European Commission. Here we see one of the global land cover maps. This one is at 100 meters resolution, but they do have a new product coming soon that also gives global land cover at 10 meters. Moving from, gone the wrong direction, going from the global to the regional now. This is a land use map that shows regional changes in Europe. So we can see from this type of data how things like forests have been decreasing and urban areas have been increasing. Sorry. This one here is one of the maps that shows particular priority area monitoring of areas that are specific areas of interest, also known as hotspots. So tailored and detailed information, in this case from the N2K product, which focuses on biodiversity. Systematic monitoring of biogeophysical parameters helps us to understand the status and evolution of the land surface. The products are used to monitor vegetation, the water cycle, energy budget, and terrestrial cryosphere variables. The kind of publications that come out give regular maps, such as this one, if I can advance it along, of where we're sitting now in Brussels, where you can clearly see the difference between the built-up urban areas and the parks, even in false colour. The European Ground Motion Service measures slow ground displacements, including landslides and subsidence, as well as any deformation of infrastructure. Many Europeans will probably recognise this one as a map of Amsterdam. As a whole, the Copernicus Land Monitoring Service supports applications in a variety of domains, such as spatial and urban planning, forest management, water management, agriculture and food security, nature conservation and restoration, and rural development. The Land Monitoring Service supports crucial elements of the Green Deal, such as climate action, clean energy, the circular economy and sustainable industry, building and renovation, zero pollution, nature restoration and biodiversity, sustainable agriculture, and sustainable mobility. Moving on to another of the early services to be implemented, the Copernicus Emergency Management Service. This service helps with on-demand mapping in emergency situations. Here's a recent example of flooding in Scotland. The service also works on early warning and monitoring to help prepare people for emergency events, such as floods, droughts, and forest fires. The Copernicus Atmosphere Service became operational in 2015, at the same time as the Marine Service. We'll hear more about atmosphere monitoring shortly, but the service does have products that deal with the ozone hole, with emissions from fires like this one pictured in Canada by Sentinel-2, and of course greenhouse gas emissions. Moving on to the Marine Service, also becoming operational in 2015, it's implemented by Mercator Ocean and deals with the White Ocean, the Blue Ocean and the Green Ocean. That is, ocean areas with ice, water and the biogeochemical parts of the ocean. Like the other services, it combines data and observations from space, on the ground, high-performance computing, scientific expertise and modelling to give us a picture of our global ocean, and for publications like the annual Ocean State Report. This report's available online at marine.copernicus.eu and helps provide information to people who need to know about the global ocean, everybody from scientists to decision makers, people in the blue economy whose businesses depend on the ocean, and for the general public. Finally, to the most recently implemented service. The Copernicus Climate Change Service, also known as C3S, became operational in 2018. Since then, it's become a vital part of the climate monitoring landscape, with publications such as monthly climate bulletins, seasonal forecasts, and the annual European State of the Climate Report. We're delighted this morning to be joined by Dr. Samantha Burgess to tell us more about the service and how it can be used across Europe and around the world. Samantha, please take it away.
Thank you so much, Ruth. And if my slides can be visible, please. So as Ruth mentioned, C3S is the youngest service, but is really a transversal service because obviously the climate system touches all other elements of the Earth system, including the land, the ocean and the atmosphere. So the data that's free and openly available on the Climate Data Store covers a range of different time periods, which includes observations, reanalysis, seasonal forecasts and climate predictions, so that we can cover both the past to understand our historical risk and historical extremes, to our future so we can understand how the choices we make influence the type of future that we'll have in terms of our future climate. Next slide, please. And as Ruth mentioned, we deliver a range of different climate intelligence products, which include mapping types of climate indicators such as heat stress. So in 2022, Europeans suffered more heat stress than ever before. This was one of the key features of our report published earlier this year, and this information was up to date until this year's summer, of course. And the European State of the Climate Report is a huge community collaboration where we have 73 contributors across 36 organizations all across Europe. And one of the benefits of an accessible State of the Climate report like the European State of the Climate is that it's suggested that it's an invaluable resource for policymakers in Europe. And this was a quote from the Belgian Minister for Climate, Zakia Khattabi, earlier this year. Next slide, please. We've seen a huge number of records in 2023, and the last 5 months have been record-breaking in isolation and collectively. So we've partnered with organisations like the World Meteorological Organization and the United Nations Secretary General when he coined the term global boiling in a press release and press briefing in July, and used our data to show just how much warmer the summer in 2023 was from previous years. Next slide, please. When we look at the daily temperature anomalies, we're able to map this not only to the modern reference period, so to understand how different 2023 is to our climate normal, but also to compare it to pre-industrial. So when we look at comparing our climate to the pre-industrial time period, we can see that within 2023, we've not only had days, but also weeks and months above 1.5 degrees. And earlier this month, in November, we had 2 days above 2 degrees. So this was a temporary exceedance of 2 degrees. It doesn't mean we've broken the Paris Agreement, but what it does mean is we're drastically running out of time. Next slide, please. And one of the benefits of the C3S program is creating a global reanalysis, such as we can see on our screen, which includes rescuing historical data so that we can reconstruct historical storms. And the animation you can see on your screens now is a storm that hit the Iberian Peninsula in the early 1940s. And we can compare our data with the observations in the time and show how useful this is as a tool to create maps without gaps. So for countries that don't have observations going back through time, reanalysis is the ideal tool to enable them to understand change. And next slide, please. And the final example that I'd like to give is another international organisation, IRENA, the International Renewable Energy Agency, which has used ERA5 to map out renewable energy infrastructure for a continent such as Africa. And this map shows the best locations for both solar, photovoltaic, and onshore wind. And this type of information really enables decision makers around the world to implement decisions for our climate future. Thank you very much.
Thank you very much indeed, Samantha. We're at the start of December 2023. You mentioned there it's probably going to turn out to be the hottest year ever. Can you describe a little bit what kind of observations or modelling we might still need to understand our climate even better?
Yes, of course. So one of the things that I glossed over was our Earth is better observed than it ever has been in the past. So the reanalysis product that I talked about, that gives hourly information at every single grid point in the world, and those grid points are 30 kilometers squared. And every single day, we have approximately 1 billion observations that go into this product. So our world is very well observed, but obviously this is still at a 30-kilometer grid. So we need to work with others in the climate service community to downscale and bias correct this product to make it relevant at city scale. And we also need to update climate projections and make sure that they're regionally relevant as well, so that we can not only make decisions at a global level, but also at a city level, so that people can really plan for the future that they'll be facing directly.
Thank you very much. Well, I'm sure we'll have some more questions about that later in the programme as well. If you do want to ask some questions of our panellists today, we are opening a question and answer session on Slido. You're able to ask your questions there, and also please let us know which of our panellists you would like to address your question to. We'll talk to Samantha again a little bit later on. But we now move on to our second speaker, who's here from Deutsche Wetterdienst, and that's Andrea Kaiser-Weiss. She's already had one side event running already today in COP28 out in Dubai. So it's been a busy morning, and thank you very much for joining us, Andrea. Please take the floor.
Thank you for the invitation. It's a pleasure to be here. And as a start, I'd like to show a video. What would it look like if we could actually see greenhouse gases? So here's an example from the Downstream blasts, which gave a huge methane concentration plume over Europe. This animation covers 5 days, and you can see the plume is swirled around by weather systems and mixed with the surrounding air. This is easy to model with our numerical weather prediction models because it's only one source. In reality, it's much more complicated. So I brought a presentation which addresses the, I have to go to the next slide. I brought a presentation which addresses our national project, Integrated Greenhouse Gas Monitoring System for Germany, where we don't look at a single point source, but look at a whole bunch of sources from industry, agriculture, soils, waste sector, and land use change and forestry. Oh, this is the wrong slide. This is not my slide. Yeah, that's better. As you can imagine, we can drill down into emissions in Germany, but as the greenhouse gases are long-lived, we also need the information from outside Germany. And that's why we use and need to use and like to use Copernicus data, which give us some prior idea about what the emissions look like. So we use this for our regional modeling together with the concentration fields, which are in this picture the thin blue frame, illustrating that at the boundary of our system we need to know what comes in and goes out. So it's 2 sides which contribute to our national initiative. On one hand, the emissions, on the other hand, the concentration modeling, which comes from the global modeling from CAMS. So we use this information to drill down in our national scale. And I hope to see another slide. Yes. Just for illustration that we combine the national inventories with our numerical weather prediction models and the information we can get at the boundary from CAMS, the Copernicus Atmosphere Monitoring Service. We combine this with the informations which could be either from ground or in situ data or remote sensing, so also aircraft or satellite data or even balloon soundings. So we try to collect as many observations possible and combine it within our numerical weather system with a technique called data assimilation to find spatially and temporally solved observation-based emission estimates with the aim to address different sectors. So you see an example on the right-hand side where you could see Germany and the counties we call Landkreise. These are the methane emissions we got from the UBA, the Umweltbundesamt, just to give you an idea about the spatial and resolution we are aiming at. So there is a societal need for emission verification, which is addressed by our national project, and it needs Copernicus for the high quality background concentrations, also for the observing system expansion, so satellites. We also like very much model and inversion comparisons and scientific exchange, and we hope that our concerted communication can help the decision makers to do efficient emission mitigation. Thank you.
Thank you very much, Andrea. So looking at those regional emissions and the different sectors they can be useful for, what kind of benefits are there for citizens or for the other users in those sectors?
Yeah, so one has to keep in mind that the decision makers are either national or regional for different counties or at the city scale. So we like to address these needs They might have special questions like, what in my area are the largest emitters and have they changed? So we would like to provide these decision makers with information. And on the other hand, we also support, of course, our national agency responsible for reporting the inventories, that is the Umweltbundesamt.
Thank you very much. I'm sure there'll be many more questions, particularly with the first global stocktake of greenhouse gases coming up at this COP28. Do please keep your questions coming in on Slido. We'll have a roundtable once all of our panel have spoken. Our next speaker will be Dr. Bart van den Hoork, who is Scientific Director at Deltares and also the co-chair of Working Group 2 at the IPCC, a working group that really covers a wide range of our topic this morning with respect to how we deal with climate change and how we adapt to it. Bart, thank you very much for joining us. Please go ahead and speak.
Yes, thank you very much for the invitation, and it's really great to be here. I was indeed also on another session this morning, and it's great to be there online as well, and to take actually the opportunity to both give a bit of advertisement to the Copernicus products for climate assessment, but also to a call to the community to look at it more carefully. If you go to the next slide, you can see a typical product of IPCC's Working Group 2 in the previous cycle is what we call these burning embers, which is a representation of, say, risk profiles dependent on global warming for specific sub-regions or sub-domains or typologies or whatever. And although they are very powerful in communicating that there is a relationship between the local risk or the spatially aggregated risk and the global warming, they're pretty coarse scale and sort of converge and convey a message that everything is kind of gradually increasing. But if you look at the next slide, it was a slide that Samantha also showed. If you look at the real world, you see a crazy year of 2023 where we see record temperatures. If you click the next slide, we see record sea ice retreats as well on the next slide. We see, and the next slide also shows a metaphor for an extreme amount of wildfires everywhere and everything. And that is, if you press one slide further, that is how the real world looks like, which is very difficult to catch in these generic scenarios. The IPCC in the previous cycle, you can see on the next slide, also provided an elegant atlas that is publicly available, and that is allowing a lot of people to search through all the scenarios and data sets that have been used for the IPCC assessment. And here, if you click once more, I think you will show up the Horn of Africa appearing. This is an analysis that you can do on that interactive atlas that shows how the global warming will affect the regional amount of rainfall. And we don't see the shape of the area anymore, but this scatter plot that you see on the left-hand side has temperature on the horizontal and vertical, the change in the rainfall amount. And so the message conveyed from this figure is, future warming will lead to a more moist area, a moist climate in that area. But if you actually follow the news, even the news of the past few years, you can see on the next slide, drought is, of course, the most prominent feature that has emerged, which is not, converging with that message that is conveyed by the picture on the left. Very nicely, if you click one slide further, more and more, say, these events or episodes of abnormal conditions are being assessed through a lens of climate change. And here's an analysis that has been put forward by what we call the World Weather Attribution Program. They are looking at events like this and by tearing apart what the physical mechanisms behind these events are. They can also give a statement on how climate change is going to affect the likelihood or intensity of events like this. And you don't need to follow the exact cartoon that is shown here. It's just an iconic picture of the attribution, the climate attribution of drought in the Horn of Africa, which is, of course, much more likely if rainfall declines, but is also much more likely if evaporation increases, and that is, of course, a very prominent feature of global warming as well. And so they have assessed that due to that warming and the impact on evaporation, the risk for droughts is really increasing despite the increase of rainfall that is projected on the mean side. So we are from working group 2, and that is on the next slide, I think we are calling to the community to really take, a climate perspective, but read it through a weather lens. I would call it. It's the weather that is affecting societies. It's the weather, the events that trigger a lot of decisions and trigger a lot of awareness on both the necessity to limit global warming, but also the need to do something about it via adaptation at a local scale. So IPCC, we are really, actually the climate itself is already releasing the message that urgency or an extreme change is taking place. The IPCC can just rely on climate to tell that message. I think for IPCC it's also important to convey the message that it's urgent to consider the actions that are needed, and not only the mitigation actions, of course, but also, and that is working group 2's domain, think about all the adaptation actions that need to be in place. And that is a complex business. Decision taking is a complex business because so many trade-offs that you have to take into account. And for adaptation, for instance, the cost benefit, but also the current investment versus the long-term revenues. That is a very, very important and very difficult practice. And so I also call up to the community to not only look at how the climate has changed, maybe not even only look at how the impacts of climate change are going to look like, but also spend a bit more time and produce a bit more literature on testing which kinds of interventions, which kinds of policy actions actually make sense to avoid large impacts of climate change. So an action impact assessment is really at the heart of supporting decision making to evaluate what action is actually best suited for that. And so we also really desire to engage a lot more with action holders. I've got one more slide, and that is a bit of an advertisement for the first report that will come out of IPCC, and has already been decided in the previous cycle. In April 24, we will set up a scoping meeting for this first special report on climate change in cities. And we have, maybe some of you have seen the call for nominations to attend that scoping meeting. About 100 people will come together to set the outline of that first report. And we have very strongly called also upon non-scientific experts like in policy making or practitioners or consultancy or whatever to also be part of that community that is setting the scene for this important report. Because at the city scale, that's where the action is, both in the mitigation and in the adaptation. So that's, I think, what I would like to say, and I'm really happy to engage in the panel discussion on this topic. Thank you.
Because it's only this year that you were appointed co-chair of the working group. So can you tell us a little bit about the process and how people are able to engage with the IPCC?
Yeah, for the nomination for this scoping meeting for the city report already closed, so there's too late. But if you are feel eligible or interested to participate in either scoping meetings or as an author, first thing you should do is look for your focal point in country, because we are calling these authors and scoping meetings experts via the focal points of countries. So make yourself known to be interested. Also, there is lots of, nationally organized webinars, seminars, or networking events to discuss findings of IPCC, to discuss future desires to IPCC, to discuss the agendas that are, or say the wish list of future IPCC reports. So also look around in your own environment and look for these networks. We are setting up sort of what we call a technical support unit, so kind of a bureau that is supporting the compilation of these reports. In the bureau that we are setting up in the Netherlands for Working Group 2, we also are recruiting what we call a science network officer, which is a person that is mapping all the science policy interaction networks of both scientists and policymakers. And so it's well possible that you will find some of these people around that is looking out for networks that could contribute to the IPCC reports.
Well, thank you very much. We'll dig a little deeper into your work in the roundtable that's coming up. And do please keep your questions coming in on Slido, particularly if you have questions for Bart, who's just spoken. And now we move to our final speaker, who joins us from VITO, the Flemish Research Institute. And I'm happy to have with us here this morning in person, Dr. Sten Janssen. Please go ahead and take the floor.
Thank you very much for the introduction, Ruth. So indeed, at VITO, we position ourselves as a so-called downstream service provider of the Copernicus data sets. And so we've developed a toolbox under the Atmosys label, which is actually taking data from the Copernicus services, mainly the air quality CAMS service, and turn that into operational tools for end users. And so this gives a bit of an overview. Actually, the first building blocks of our Atmosys toolbox were developed 20 years back in very close collaboration with our National Environment Agency for the Belgian situation. But since then, with the help, amongst others, from an important LIFE project that was funded by the European Commission, we've really tuned this toolbox into a couple of models and services that can help member states in the implementation of the Air Quality Directive. And then, since then, we have applied it in a number of member states. We started it in Poland in 2016 and then moved on to Croatia, Hungary, Slovakia, and now recently also Ireland. Really working in very close collaboration with the EPAs in each of these member states to support them in the implementation of the Air Quality Directive. And actually, during this journey, the availability of the CAMS data, which gradually came available, was a great help to support us in this process. And just to give you a few examples of the type of products that we use, on the left-hand side, you see an air quality map provided by the CAMS platform, which gives us a first indication of the background concentrations, but then by including additional local source information, local in-situ information, we're able to increase the resolution and actually make it more tangible, even more suitable for local policy actions. So this is an example for an air quality map here in Brussels, where we're now today. And this type of maps are used by local policymakers to actually develop and implement their policies with respect to air quality. Another example is given here in Croatia, where we have developed a forecast system. Also there we can make use of what is Copernicus already providing today. And as you can see in the bottom panel, which is giving the forecasts in comparison to the observations in one of the stations installed on an island, Copernicus is actually doing a very good job. That island is is picking up not very strong sources, and so the regional forecast is doing is giving a very accurate prediction actually. However, when we move on to an urban environment, and that's the graph in the middle at the top, there you see that some local peaks which are produced locally are not very well captured by the regional scale forecast of Copernicus. And actually then by adding our local information, teaming them up with the local environment agency, enriching this Copernicus data, we're able to provide an even more accurate service for that that station or that location in that urban environment, giving rise to a more valuable product for the local policymaker in that area. Actually, the same is true for the project that we did in Ireland. Also there, we started from the Copernicus data set. Also here, we see that Copernicus, on average, is giving us a very good first starting point, but some local peaks are not very well captured by this regional forecast. And here again, you can see in the red graph, which is our local forecast, it's really now picking up the peaks which are observed in reality and which are not captured by the Copernicus services. So that's a bit the philosophy we follow. We start from a Copernicus data set, what you can see here. So we've set up our Atmosys modeling system so that as a first starting point, it can rely on all the different data sets that are provided by Copernicus and which are relevant for our services, mainly the CAMS, but also the C3S that was mentioned before, and the land data. And then when we deploy the system in a particular area, we see if we can gradually improve some of this, call it European-wide service with some local information in order to produce more accurate data at a very local scale. So up to now, I showed some examples for Europe. We're also active in other parts of the world. This is an example for a service that we have developed for Bangalore in India, where we also made use of the Copernicus global data, global forecast data. And here again, we follow the same approach, working very closely with local environment agencies, trying to collect local information, feed that into the global Copernicus forecast in order to produce then a forecast system specifically tailored for the needs of this city environment agency. So that's it in a nutshell.
Thank you very much, Stijn. So what comes next? You said you've moved out from Europe to India. Are there other developments coming for your program?
Yeah, so actually, as we speak, we are now starting a project in the Middle East, and we're also already since 2011 we're active in China, and also there we've seen that Copernicus is bringing added value there, and that our colleagues in our Chinese office can make also use of the Copernicus data for the Chinese continent and make use of this Copernicus data as a first starting point, again enriching it with local bottom-up data in order to produce reliable results for policymakers and reliable actions.
Thank you so much. So these particular projects have been dealing quite a lot with the CAMS data. Are there other projects that are under development that can use other Copernicus services in a similar way?
Yeah, as I showed in one of my slides, indeed, we also make use of meteorological records, of course, which are extremely important in the air quality assessment phase, because this is heavily driven by meteorology. So we make use also in our reanalysis, for example, of ERA 5 data sets. And of course, land use is also a very important component in the modeling system that we use. And also there we can rely on Copernicus data from the land component, definitely.
Great, thank you very much. So moving on to our questions from Slido and the roundtable. I also invite all of the panelists to ask each other some questions. First question is from Andreas, and it's quite a complicated question. You need to explain the question to me as well as the answer, please, Andrea. How capable are the Copernicus tools in dealing with stratospheric water intrusions and its impact on the radiation forcing?
I think that's a question for Samantha. Because it's the Copernicus tools.
Samantha, can you pick that one up?
Yeah, sorry, the sound cut out, so I missed the question. If you could repeat it, please.
The question is, how capable are the Copernicus tools in dealing with stratospheric water intrusions and its impact on the radiation forcing?
That's a really good question, and it's hard to give an accurate answer in this type of forum. But I think the stratospheric component of ERA 5 is fairly reliable, and one of the benefits of services like Copernicus is all of the documentation is available on the climate data store, and this documentation includes technical documents which assess the quality assurance of the data set. So I would encourage the person asking the question to go to the climate data store, look at the technical information, look specifically at the stratospheric variables to understand water loading and how it's changed through time.
So I imagine you get quite a lot of questions from users as they access the data, Samantha. How do people interact with the climate data store generally?
Yes, so we've got a excellent user support program at ECMWF. So I think the website, the email address is something like usersupport@ecmwf.int, and there's also a user support forum. So as you can imagine, many people asking these questions. If they're a new user to Copernicus data, those questions have been asked in the past, and there's a community forum there that establishes how people have worked through these questions, many of these questions in the past.
Thank you. So as I mentioned earlier, we're coming to the very end of 2023. In 2024, there are a considerable number of elections going to be held all over the world involving large populations. So I wanted to know from our scientists today how often they're invited into conversations to help form policy. Stijn, maybe start with you.
Yeah, it's an interesting question, actually. And I think this is actually a very important part of our job. So since we're working mainly at member state level, at local level, we're actually very much involved in actually the development of air quality plans, not in the political decisions, of course, but we support policymakers in trying to make the right decisions. And actually, for example, in Belgium, we're working on the national air quality plan that is being developed. But also in some of the other member states that I presented before, we're participating in that process. And also, for example, now, as we speak, the European Commission is discussing a new air quality directive. And also there, we're somehow supporting how modeling systems can be or should be embedded in this renewed air quality directive and how they can support policy making.
Cool, thank you. Bart, you mentioned a little bit about the dynamics of the IPCC and connecting with different countries. Do you get invited into the rooms where it happens in terms of policy making?
Oh yes, quite frequently. But maybe not too much in, say, by politicians, but there is a larger group of experts in the policy making arena, which are more, say, the support staff or the policy preparation people, I would say. They actually consult IPCC reports for pretty technical reasons. We see IPCC results, of course, emerge a lot in more political processes, but then more like an underpinning narrative for policymaking. Also for the conference that is taking place right now in Dubai on the policymaking on greenhouse gas emission reduction, for instance. If you look at the preparation documents that are sent in by all the member states of the UNFCCC, IPCC is referred to quite often, but then primarily as a motivation or setting, say, boundary conditions for the policymaking. So, but I'm pretty involved in the Dutch policy making on climate adaptation, waterproofing, water security things, and IPCC is sort of a reference. But of course, a lot of local tailoring needs to be applied to make these IPCC outcomes relevant for the local policy making, and that's also my personal ambition for the next series of IPCC reports, that we try to improve, say, the local recognition of what actually is at stake at the local level, because these mainstream, say, globalized scenarios, they are well suitable to support, say, policy making at a global scale, but need a lot of interpretation when you bring it down to the regional scale.
I mean, that's a great point. How do you find that people internalize the information that they're getting to actually consider how to take action, Bart?
Yeah, and that is to relate to their own context, for instance. And there's a couple of things that you can flag. We all know that people are more receptive to taking the implications for granted for instance, for extreme weather, closely after an extreme weather event has been recorded in their own environment. And like the major flooding that was in Central Europe, in the Netherlands there was quite a bit of damage in July 21, but of course in Germany, Belgium, that was much more devastating. But then that triggers, of course, a lot of local discussions also on water, not only on water resilience, but also on climate change. And I would not plead to make every event frame it as being caused by climate change, but every event contains a lot of lessons that can be learned from how climate change could look like. We can not only try to, say, attribute the probability of such an event to climate change, such as the World Weather Attribution does, but we can also, as we did in the Netherlands, we can put that same event at another location to see what the impacts would look like in another area. And if you have a different water management system, like in the Netherlands with these large polder areas, and then you get 200 millimeters of rainfall in 2 days, and you have a pumping capacity of 20 millimeters per day, you can imagine how long that large area, including Amsterdam, that was just shown on Samantha's figure, is going to be flooded with a lot of water. And although that is not per se climate change adaptation, it does reach emergency response and on spatial planning people that have to deal with the water management, triggers a lot of, it gives a lot of information about their implementation of future conditions. And that is, I think, a very useful way to bring climate change to a local context.
Thank you. Andrea, you were talking to us about the emissions verification and those kind of concentrated local projects. What happens next with those, and what's it like for the people who are actually living in those areas?
Yeah, so first of all, I think it's great that in the last years, the general perception about the problem of climate change is trickling down in society, and also the policymakers do approach the scientists. And there are plenty of invitations coming in for German Weather Service to give the expert view on this. I think one problem for the local decision makers is that their relative contribution is of course small if you see the global picture. So I would also like, because Bart raised it, like to focus on how do we make sure to encourage the local action, although there are so many players who have also to give a contribution for climate mitigation. Yeah. That's a challenge, I think.
Maybe bring Samantha in here, because I know she does a lot of interviews and is dealing with a lot of media from global down to local scale. How do you see that challenge being met?
Yeah, I think it's a really important point that Andrea's raised. And we see climate action at a huge number of scales. So not only at national levels, which is obviously what the COP28 is all about, but also from businesses, from different sectors of society, and from cities taking leadership roles. And we've got some tangible examples of how C3S data has been used in decision making. So myself, I speak regularly across the Directorate Generals in Brussels to ensure that DG Klima, DG Environment, DG Agriculture have access to climate data and are building that into how they're writing future policies, particularly for the Green Deal. But there are other international examples, and one of the recent examples from a Belgian scientist, they used ERA5 and looked at ERA5 data associated with photovoltaics for a country in Africa, so similar to the map that I showed from Marina. But what they were able to show, they're engaging directly with the Environment Ministry there, and that particular country then chose to invest in a solar farm rather than a international aid-funded coal power plant, because the return on investment and the sustainability for the local community of that solar farm was better in the long term. So they were able to reach that agreement at national level, and climate data is integral to making those decisions. So there are lots of these examples around where nations and cities are making these decisions based on data. But as always, it's a conversation and ensuring that people understand what climate data can do and what it can't do. And this is why we also refer to the IPCC assessment report so much, because obviously where C3S works is the physical science basis, so working group 1, but working group 2 and working group 3 are also very important to ensure that that physical science can be built into society and understand the risks for society.
Well, thank you very much. We should mention here as well that this year has seen the launch of the Copernicus thematic hubs that bring together Copernicus services under banners such as the Arctic, energy and health, to allow people to access the information and potentially become users of services that they haven't been involved with before. And I wanted to ask Stein a little bit about this with respect to not just institutional users, but also potential commercial users or developing opportunities through all this data that's been collected.
Yeah, I think as we demonstrated, I consider myself a bit as a data user of the Copernicus. So we try to make use at best of what Copernicus is offering. But we also see indeed, for example, in Ireland, where we're now deploying these air quality services, that then is also triggering local actors to further build upon the data that we provide. For example, healthcare agencies, they pick up on the air quality forecast that we provide, or that the agency in the end is providing, in order to inform their patients or their citizens about upcoming events. So indeed, there is a wealth of data available, both at continental scale. We try to make it even a bit more local scale, and we always offer this in an open space and in the public domain, and so that offers a lot of opportunities for other players, even also commercial players, to develop their further services on top of that. So
Thank you. Yeah, and just maybe to bring Bart in again on that, because of course your working group does work on all of the socio-economic inputs and outputs related to climate change. Is there a possibility to help people use data for wider benefits, some of which can even be commercial?
Oh yes, for sure. And there's a lot of commercial interests from all kinds of sides, not only in the, of course, in the mitigation area for renewables, but also in adaptation, like business of insurance business or investment analysis of how exposed real estate is to climatic risks. So there's a lot of business interest also in the impact assessment and impact reduction business. So and also there is very professional analysis of what IPCC reports and what Copernicus products have to tell about these risks. So yes, there's a very large, I think, propagation of knowledge and data and information also into the commercial area.
Thank you. So, Andrea, we're looking at COP28 as being a big moment for the global greenhouse gas stocktake. Can you tell us a little bit more about it and how your projects are interacting with it, please?
Yes. By using the observations of the atmosphere to draw conclusions on the emissions, we provide a different kind of view on the emissions. So we add some transparency or extra information to our inventories. And this is an example how we support the stocktake on a national scale in Germany. And we hope to inspire other countries also to do something similar. And there are already some other countries doing that. So if we team up, for instance, with WMO, World Meteorological Organization initiative, or Global Greenhouse Gas Watch, then we have a chance to use observations all over the globe to do emission verification all over the globe. So that should help the global stocktake.
Great, thank you. I know we have a YouTube live event coming up on Tuesday that deals a little bit more with this question of why are emissions still going up and are they ever going to come down? In just a moment, I'll be asking the panelists to each sum up their positions and thoughts on COP28 and what their interactions are with this ever-increasing problem of climate change. But I wanted just to check in with Bart again, just about what his personal view is going into this IPCC cycle. When does it officially give results, but when can we start to think about what results it might be delivering in this 7th assessment cycle?
We are going to make, of IPCC is going to make a decision on how the cycle will look like in January the coming year. Then the next panel meeting of IPCC will decide on which reports will be produced and what are the timelines of all the reports. And we have, of course, there is already been a request to member states of IPCC what kind of preferences they would have. And many countries, of course, do indicate that for the next global stocktake in 2028, they would appreciate some input from IPCC, like also that AR6 has been very influential for the current stocktake. And so that is to be discussed and decided by the panel, but we are preparing a couple of options of how the cycle could look like. And we do take into account that maybe that first special report on cities will probably be delivered in time to be part also of the technical assessment of the stocktake that already starts somewhere 27, I believe. And maybe another special report or some kind of a timeline will be adjusted to that stocktake. But yeah, that is on the table still, and that's not up to the co-chairs to decide. It's up to the panel to decide, of course.
Well, thank you. We'll be keeping watch next year. So now we'll return to the panelists, check if there's anything that they wanted to add today that they didn't have the chance to add, and give them an opportunity to sum up. We'll go in the same order that we went from the start. So that means we return first to you, Dr. Samantha Burgess, please.
Thank you, Ruth. And I think two of the messages that I would like to ensure the listeners and viewers take away with them. One is, of course, there's no reason for inaction between the IPCC cycles. And one of the fantastic examples that Bart gave was the IPCC Atlas, which the Copernicus Climate Change Service has adapted, because obviously the IPCC cycles are fixed in time, but the science continues to build and the data continues to be updated in between those cycles. So there are lots of opportunities for free and open data between those cycles, and there's really no excuse for inaction, because the Copernicus enables a range of different data products that range from incredibly complex to very simple and accessible, so that if you're interested in how climate will impact you in the future, there is a type of tool that is relevant for you and your decision-making requirements. I'll leave it there. Thank you.
Thank you very much, Samantha. We look forward to the next monthly climate bulletin coming from C3S next week. I should invite you as well for another Slido poll to see how this session may have affected your thoughts about the Copernicus services and their ability to help the green transition. While that's going on, I'll ask Andrea Kaiser-Weiss to give us her closing statement, please.
Question with how useful so just to make a point, I do feel the Copernicus service is extremely useful for our task. What I take away from the session is that we have to use and combine forces at the global, national and local scale to support the decision makers doing good decisions, to reduce emissions. And we have the data, we have the modeling, and we just have to help them to do the right decisions.
Thank you. Moving back to online, and Bart van den Hurk, please.
Yeah, to follow up on Samantha's reference to the IPCC Atlas that is now incorporated by Copernicus, which we really appreciate, of course. I happen to be part of the chapter that developed the Atlas in the previous cycle, so I'm very happy about that. But now being in work group 2, we are of course looking forward to making it also a working group 2 relevant kind of. So we are thinking about putting an extra layer, systematic impact data, and maybe also even policy evaluation data. That would of course be really, really great. So I'm happy to keep on discussing, say, future releases of the Atlas that also incorporates more climate impacts and impacts of climate interventions or adaptation interventions. That would be a real great outcome of AR7, I believe.
Thank you very much, and thanks for joining us, Dr. Bart van den Hurk. And finally, back to our studio and Sten Janssen. Any closing statement from you, please?
Yeah, I would try to make the point that indeed we further have to explore, I think, the synergies that exist actually between air quality, which are brought in here in the panel, and the climate, because they're very closely related and people not always realize that, but they share the same atmosphere because climate has an impact on how the atmospheric chemistry is working. They share in very often the same sources, because it are the same sources which are emitting the climate gases, but also have the impact on the air pollutant emissions. And maybe even the adaptation strategies that were mentioned before also can have an impact both on climate and air quality. For example, if we further are greening our cities, making our cities more livable, then also that will have both an impact on the climate adaptation and on a better air quality for people that live there. So I think we should further strengthen both topics.
Well, thank you very much for joining us today, and thank you to all of our panelists and to everybody who interacted with us online today. I wish you all a very good and positive COP28 over the coming days. And I also would like to thank our hosts here at the European Commission for taking care of us this morning. You'll be able to see a replay of this event and of all of the other EU-side events on the same platform and YouTube channels that you've been watching this morning. So I'd like to extend my appreciation to all of you and wish you all a very good day. Thank you.